Next up, we have two individual presentations. The first one is by Dejana Ugrenović from United Cloud, and she will talk about what on earth is machine learning and artificial intelligence, a quick tour of machine learning, AI, and data science. And then Uroš Simikić from Trilateral will tell us more about understanding meta-humans as a virtual identity standard. Dejana, the floor is yours.
Hello everyone, my name is Dejana Ugrenović and today I will give you a quick tour on a presented topic. We only have 10 minutes, but I will try as much as possible to give you takeaways out of this session. So in order, if you want to continue to exploit these technologies, you can learn something of it. I have a mixture of industrial and academic research background, and currently I am working as a machine learning product manager at United Cloud. United Cloud is a leading innovation center in a region, and with artificial intelligence in its core, we are developing end-to-end next generation products for media and telco business. My team and I are working on various projects such as short-form production, advanced content discovery, personalization, all that powered by the platform of the future, Leon. The global market trend for the machine learning is more and more expanding, and it's predicted to get more than 300 billion by the 2030. And there are many startups for the machine learning. And regarding the hype cycle, there are some applications and fields that are going to be much more expanded, and some that still need to be on a more mature level in 10 years or so. However, these days you are all surrounded by machine learning and artificial intelligence, where you have it in the social media, Google, Facebook, also for the healthcare. The autonomous driving is an interesting application, of course, as well. Smart bots, recommendation, but what is it in its background? The term occurs since the 1950s, where the group of scientists said, okay, this is something that mimics human brain. There is no specific definition on artificial intelligence. It's a paradigm, and the machine learning is actually trying to train the machine to learn without being explicitly programmed, which leads us to our first takeaway: the difference between classical programming, traditional software development, and machine learning, in which first we have rules, we have data, and we always have deterministic output. In machine learning, we don't know always how the model will behave. And based on the data and the answers, we create set of rules that are later able to make predictions and classification. Machine learning heavily relies on mathematics and also combination of the algorithms and computer science. And there is a huge data stack behind the data science and machine learning, in which many libraries developed and implemented that enables exploitance of these technologies. But why would we even want to use it? I like to start with disadvantages. It's very much painful process, and many time and resources are being spent on it. It's not so easy to it's sometimes very easy to confuse it. Also, like something that is a bit difficult for human also, but something that is trivial for human, for machine learning, can be very confusing. Also some safety issues. But despite all of that, there is a huge potential in this technology, and industries much like to use it because it, of course, cuts costs and enables new sources of revenue. There are, now we know why we want to use it. There are three main types of learning, which is supervised, unsupervised, and reinforcement. And in this short talk, we will focus on, and this is actually the second takeaway, these three types of learning. And in this short talk, we will focus on supervised learning, which is basically can be explained if the model is a toddler that tries to learn based on what moms tell him, what is this brick, this is yellow, this is green, this is blue, this is circle, this is a triangle or a ball or similar, and then when the new input arrives, the new brick arrives, the toddler know, okay, mom told me this is something that reminds me on this, okay, I make a conclusion what it actually is. However, in unsupervised learning, this is a bit different, where this baby or toddler tries to learn based on some patterns, to group it, to make some similarities between these toys. And in reinforcement, we have it's based on rewards and punishments. But for the supervised learning, as I said, which will be focused, we have the data set that is being labeled. We are told to model what is it, and then we use some mathematical cost and optimization functions in which we try. This is just some simple way of explaining. We are trying, for example, to fit this curve between these points to make a minimal errors. And there are two main types of supervised learning, which is classification and regression. For example, if we look for the time forecast, in regression we have continual outputs, while in classification we have discrete limited number of outputs. And to tell you more about the machine learning procedure, if you look at this simple data set, this is a classical one for the loan prediction risk analysis. We have some features, we have some data sets, and we want to understand what will be the outcome for the next user. In this case, and this is the third takeaway, what you have all to do to make your model successful. You start by gathering data, and you start by exploring it and looking in its outliers. Is it limited? There are many missing values and similar. Then the fourth takeaway, and something which many industries don't understand, the level of the domain expert, in which you need to talk with the person that have a lot of experience in the problem that you want to resolve as a machine learning. So just as the symbiosis between these two expertises, machine learning with the domain ones, are the formula that are likely to give a successful model. Without it, it's not that easy to achieve success. After we train the data and do the feature extraction, then we gather the data and did the feature extraction. We are training a model on our training data set, and then we do the evaluation and realize it's not good. For example, the testing accuracy is much lower, and that's not what we expected on the first try. Then we do the hyperparameter optimization, which is the parameters of the model, and actually this process is something that I understand and always experience as very difficult, time-consuming, and much. This is from the heart, actually, to gain which actually hyperparameters need to be trained. After we make some success, then we want to deploy our model. And this is the fifth take away, which is the machine learning code, compare the whole ecosystem in one production, in one industry. And if you want to make it usable by users, if you want to exploit it this is just a small part of it. We need much more tools and much more resources to empower this, what we achieved. And this is where we come to data science, which is a mixture of multiple disciplines, and also many industries are not actually quite equipped with the data lakes, data sciences, which then and want to be data driven, so it requires a lot of work to make a data structure. Many data science now roles different that needs to be employed to make it successful, and that's it. Thank you very much.